Hi, this is Zoe, and I'm going to be doing a practice problem from Chapter 1, number 18 on page 54. This question asks, an important environmental consideration is the appropriate disposal of cleaning solvents. An environmental waste treatment company analyzed a cleaning solvent J and found it to contain the elements carbon, hydrogen, and chlorine only. The chemical composition of J was determined using different analytical chemistry techniques. Combustion reaction. Combustion of 1.3 grams of J gave 0.872 grams carbon dioxide and 0.089 grams of water. Precipitation reaction with silver nitrate. 0.535 grams of J gave 1.75 grams of silver chloride precipitate. A. Determine the percentage by mass of carbon and hydrogen in J using the combustion data. B. Determine the percentage by mass of chlorine in J using the precipitation data. And C. The molar mass was determined to be 131.38 grams per mole. Deduce the molecular formula of J. So for 18I, before we find the percentage, we have to find the mass of carbon and hydrogen in J. So to find the mass of hydrogen, we take the atomic mass of hydrogen and put it on top of the molar mass of water and multiply it by the amount of substance given, which in this case is 0.089, and we get 0.001 grams of hydrogen. Then we do the same for carbon and put the atomic mass of carbon, which is 12.01, over the molar mass of carbon dioxide, which is 44.01, and multiply it by the amount of substance given, which is 0.872, and we get 0.238 grams of carbon. Now we determine the percentage by mass of carbon and hydrogen in J. So to do this, we take the numbers that we just got. So for hydrogen, we will do 0.001 grams of hydrogen over the amount of J, which is 1.30 grams, and we times it by 100 to get 0.77% of hydrogen. Then we do the same for carbon, and we take 0.238 grams and divide it by the same number, which is 1.30 grams of J. Multiply it by 100, and we get 18.3% of carbon. So B asks us to determine the percentage by mass of chlorine in J by using the precipitation data. So we do the same thing that we did in the previous question, but just instead with the precipitation data. So first, they want us to find the mass of chlorine, so we take the atomic mass of chlorine and put it over the molar mass of silver nitrate and multiply it by the amount of substance given, which is 1.75 grams, and we get 0.433 grams of chlorine. Then we divide this amount by the amount of J given, which is 0.53 grams, and we get 80.9% chlorine. So the last part asks us to find the molecular formula of J. So to do this, we first take the percentages that we just got from the previous two parts. So for carbon, we got 18.3%, and we have to divide it by its atomic mass, and we get 1.52 moles of carbon. Then for hydrogen, we take 0.77% divided by its atomic mass, 1.01, and get 0.76. Then for chlorine, we take 80.9% divided by its atomic mass, 35.45, and get 2.28 moles of carbon. Now we have to divide each number by the smallest number on there, which is 0.76. So we divide 1.52 moles of carbon by 0.76 and get 2. And then for hydrogen, 0.76 divided by 0.76 is 1. Then for chlorine, 2.28 moles of carbon divided by 0.76 is equal to 3. So from the numbers that we just got, we can say that there are in J that there are 2 carbons, 1 hydrogen, and 3 chlorines. So then our empirical formula would be C2HCl3. So to find the molecular formula, we have to add up the relative atomic masses and find the relative formula mass. So to do this, we do 2 times 12.01, which is 2 times carbon, plus 1 hydrogen, which is 1.01, plus 3 chlorines, which is 3 times 35.45, and we get 131.38. And in the question, it gives us that the molar mass is 131.838. So then we just divide, and we do 131.38 divided by 131.38, and we get 1, which means our molecular formula is the same as the empirical formula, which is C2HCl3.